Hey guys, so let's talk about inverse variation. Here we go. So here's a little pattern. 1, 2, 4, 8, 16. Do you know the pattern? The values are doubling. Look at the y values. 100, 50, 25, 12.5, 6.25. The values are half. So you notice something. As my x values go up, my y values go down. This is what you call inverse variation. We're used to seeing functions like quadratic, exponential, at times exponential, and linear, right? Whereas one variable goes up, the other variable goes up as well, right? This is a little different. So I have a variable that's doubling and another variable that's being cut in half. There's a lot of neat applications to that. Let's get started. So what we're going to try to do is we're going to try to find coordinates. So if I would tell you, for example, what about if I had a random one, the value 10? What should be the output for the value 10? Well, there's something that you need to notice about inverse variation, and it's that if I take my x value and I multiply it by my y value, every single time I get 100 for this in this particular case. 2 times 50, 100. 4 times 25, 100. 8 times 12.5, 100. 100, 100, 100. Okay? To the point that if I get my x is 10, then I know for sure that my y is going to also be 10. All right? And we'll talk about a neat little graph that this creates tomorrow. All right? So here's some example problems. So let's say that I've got a situation here where my x is 18 and my y is 28. Okay, so x is 18, y is 28. And okay, so x equals 18, y equals 28. In other words, that's the coordinate 18, 28. Okay, then I've got another coordinate, and that coordinate, the only clue that I have is that x is going to be 72. So what is y going to be? All right, so you can sort of start to imagine right here. Well, you'd want to think, well, what would I multiply 18 by to get 72? So I could multiply 18 by 4, right? Which means I need to find a value y that in turn that if I were to divide 28 by 4, I would get that y value. So 18 times 4 is 72. 28 divided by 4 is 7. So that's one way of visualizing it. If you didn't much like that, I don't blame you. There's another way to tackle it. We mentioned x times y is constant, all right? As a matter of fact, for inverse variation, x, y is always equal to a constant k, all right, for inverse variation. So if we say 18 times 28, my x and my y, that should be the same as 72 times y, all right? So for this, I believe I get, is that 5, did I get, I got 504, okay, with my work. Okay, so that's 504 equals 72y, and if I divide both sides by 72, I get 7, all right? 7 is my y value. So there's a couple of ways of looking at that, okay? Now, what if I move on to a more challenging problem? So what if I say, okay, so there's inverse variation. X is, my x is 12, and my y is 4. Okay, but we're going to say x is inversely proportional to the square of y. In other words, instead of me saying that xy is going to be a constant k, all right, instead of that, I am actually going to say x is x and the square of y should give me a constant. So here I go. 12 times 4 squared should be equal to, well, let's see. We've been told that we want to find x when y is 2. So x when y is 2. And what I get for that is that x equals 48. So that's how I set my problem up. The bottom line is that I can use any of these two formulas. x1, y1 equals x2, y2, or x1, y1 squared equals x2, y2 squared.